All right, so we're in the middle of an engine swap on a 93 Ford F-150. We're replacing a 351 Windsor with a 408 stroker Windsor. Sounds like a pretty simple setup, right? Well, you couldn't be further from the truth because this engine should have been in about a week ago, but there's one part that I haven't got yet, or I've got several wrong versions of this part that have made this job until this point pretty much impossible. And I think a little bit later on this afternoon, FedEx will show up. I think they come at like 1 or 2 o'clock. And they'll hopefully deliver me the part that I ordered that's the right one, and it'll make this thing all go simpler. But after I get this truck together, I'm pretty much fed up with Fords, and I think it'll be about another 6 months before I decide to work on one again. And I'll give you this, if I knew a little bit more about all the intricate details of all the differences that Ford used between their different transmissions, their different engines, you know, and all that stuff, it might have been a little bit easier on me finding the correct parts. But I'm not a Ford guy. I don't know if I necessarily care to know all those differences. So anyway, we'll get to all that in just a second. I'm really fed up with this thing. But first, let me actually share with you 1 or 2 things that did go exactly how it should have. So we're installing the distributor, and the timing cover is already on. We're putting the distributor and the balancer on. Whenever you're installing a distributor into a brand new engine like this, one thing you want to make sure of is that you know exactly where the engine is in its timing cycle. Basically, you want to make sure the balancer says exactly where the engine is. So whenever I had the timing cover off, I turned everything over until the 2 dots lined up exactly with one another between the camshaft and the crankshaft, which meant we are at top dead center on cylinder number 1, which on a Windsor is passenger side front. And just to kind of verify that, I cranked it over 2 more times, and I watched the valve open and shut, and I made sure we had air or compression coming out of the plug. So I triple verified we are at top dead center, number 1 cylinder. Now, the next thing that we had to make sure of was that, and this is where a lot of things mess up sometimes, is that the actual numbers on the balancer made up with the timing cover, because with Fords especially, there's like 3 different timing cover options, 3 different pointers, and they all have slightly different scales. Now, this is an aftermarket balancer, and it's somewhat universal in the sense that it has 3 different timing scales on it. One here, which is the actual one that we are going to use. I already made sure of that. And then they have another one down on this side. So basically, that just goes to say, whenever you're putting a Windsor together, make sure that your timing mark actually lines up with numbers that make sense. One more thing, this is a internally balanced harmonic balancer, where some, like if this were a normal Windsor like that guy, it would be externally balanced. There'd be a counterweight off to the side here, and this will actually come to play in a little bit later. But first, I just want to talk about how easy it was to install this distributor. So normally, when you're putting a distributor in an engine like this, basically you turn the engine over to your top dead center compression stroke, just like we talked about. Put the balancer on here, so I just kind of can verify that the 0 degree mark is at 0 degrees on the pointer. And then we stab the distributor in, making sure that the rotor is facing the number 1 cylinder. Obviously on a Windsor over here. And then if this were like a normal setup, you'd put your plug wires on, start the thing up, put a timing light on with a lead on the number 1 cylinder, and flash the strobe light down here at the balancer, and then twist the base of the distributor to advance or retard the timing until it matches up where you want it to be. And that's how you set timing. But we're actually using a Holley Sniper EFI, and this is their Hyper Spark distributor, and we have the whole ignition system to go along with the Sniper, and they include a little tool that makes life like really simple when it comes to setting up timing, and that's this clear distributor cap right here. So it's molded to fit around the rotor up top, and then there's a little bump right there, and then there's a second little notch right there on the edge. So basically what you do is, once you get your distributor in and lined up with the oil pump and the rotor pointing at number 1, you take this guy and you slide it over top of the rotor, and it kind of sets down on there, and then you turn the base of the distributor until these 2 little dowel pins are right there. You want those to line up in that little notch there, and once everything is lined up, you tighten down your clamp and your timing is set. Now you do have to go into the Sniper EFI setup, and you have to type in a certain timing offset, but the instructions tell you what to do there. So basically, once you get this thing all put together, all you've got to do is get out your timing light and verify that things are where they should be, and you shouldn't have to make any adjustments if you use the little cap. The other little mark right there, basically that's just to indicate I transferred it with a marker onto the base That's just to indicate where your number 1 position is on your plug wires. So that guy right there, spark plug number 1. So just in summary, we verified that we're actually at top dead center, verified that our timing scale and pointer accurately reflect where the engine is, put the distributor in with a tool to make sure that timing is set. So now all I've got to do is use the installer tool to press the balancer onto the crankshaft. Just a side note, never ever hit that thing on with a hammer because you will more than likely mess up the thrust clearance on the crankshaft. That's not something that you want to do. So always use the correct tools. I did have to rent one from O'Reilly's. This one, it is a little bit kind of on the cheesy and flimsy side of things, but it was only, well, you pay like 50 bucks to rent it, but you get your money back. But this part right here, this little roller bearing, it is really, really flimsy. It comes with all these adapters to go into different styles of crankshafts. There's an adapter there, a long bolt that goes through the center, and then the nut right there. That's kind of what you use to press it on. So anyhow, put a little bit of lubricant on there. We'll get the balancer pressed on. So I have the balancer fully installed, the bolts on, it's tightened up, and then I just mocked up the pulley just to make sure I had the spacing on there. And now it's time to talk about a couple of the things that have halted progress and a few reasons why I'm so frustrated at Ford. And that's mainly because they use so many different variations of simple parts throughout the run of the Windsor. I mean, the Windsor small blocks went from, I believe, like the late 60s, early 70s, clear up until probably the late 90s or even into the early 2000s, you know, like in vans and things like that. They switched over the mod motor, and I think in trucks in like the 98 model year, something like that. Anyhow, they ran Windsors for a long time and they made a lot of changes. And the one part that has halted all progress up until this point is the Flexplate. Now, I made mention of this in my last video when I ordered one, which I thought would have been a super simple process. But the one that showed up was wrong, and then since then I've ordered 2 more, and hopefully the one that is supposed to show up, it's not here yet, the one that is supposed to show up today hopefully will solve my problem and I can finally get this motor dumped into the truck. So here's kind of what we're doing and a few reasons why it's so difficult, and then I'll go over some of the things that I learned which might help you guys if you're in a similar situation working on a Ford. So we are combining this. It's a 351 based Windsor. It is a 408 stroker, and because of the type of crankshaft that they use, this is internally balanced. So there's no counterweight on the balancer. I showed you that, and there is no counterweight on the Flexplate up back, and that's the one thing that's kind of hanging us up at the moment. So the original Flexplate that came on this 351 Windsor for E4OD, it's not a 4DD like I mistakenly said last time. Sorry, Ford guys, E4OD for overdrive. Anyhow, the original Flexplate right here, this is a 14¼ inch diameter. It has 164 teeth on the ring for the starter to engage, and it has a 11 3/8 inch bolt pattern for the converter. There are 4 studs on the E4OD, and the center of here to the center of here, if you measure it with a tape measure, is 11 3/8 inch. But remember that dimension because this dimension actually messes us up a little bit later on. Now, the next flywheel that I'm going to show you, this, or flex plate rather, this was provided with the kit. The owner bought this one, and I probably would have done the same thing. I just would have hopped on to Summit or whoever and ordered a flex plate and been done with it, because I had no idea that Ford had this many differences in their flex plate spacing and all that stuff. Anyway, this one, I forget the diameter. It's not 14 1/4. It's like a 12 or something like that. Pretty sure it's 157 tooth on the flywheel, but this is an internally balanced flex plate. As you can see, there is no counterweight on the side. I don't know what the converter pattern is, but when I did my reading and stuff, there is, I think, 2, possibly 3 different bolt patterns for the torque converter. One that measures in at 11 3/8, that's the one we have, and I think they call this like a quote-unquote C6 spacing, and this smaller one, I think they call it like a C4 spacing, but I'm just kind of looking here. I think they have a 3 and a 4 bolt pattern on this particular flex plate. Anyhow, because it is smaller, the starter won't work, and it won't actually bolt onto the torque converter. So that flex plate is a no-go. Now, I did a little bit more reading and I came up with a solution that will actually work, but it's not one that I am going to choose, and that's mainly because of, well, it's a safety issue. So let me put this guy down here and let me show you the one flex plate. This is actually the first one that I got, not this guy, we'll get to that in a second. Well, this flex plate right here actually will work, and this will basically check all the boxes. So this is for an internally balanced engine. It has the same 14 1/4 inch outside diameter, the same 164 tooth flywheel, the converter spacing, all that is exactly where it needs to be. Now, believe it or not, this application is for a Ford 300 straight 6. It will bolt onto the crankshaft, and it has, dimensionally, it's all the same. But the only reason why I didn't want to use this one is because of how thin it is. I think I measured in at somewhere around like 90 to 100 thousandths of an inch thick. In fact, it's just a little bit thinner than this original flex plate right here. And the reason why I didn't want to use a stock replacement one is because I've actually had to replace these on bone stock vehicles because they just kind of develop a crack over time. They'll just crack right around this middle of the flex plate here. This will stay bolted to the crank and the outer part just will crack off. And since we're going with a nearly 500 horsepower engine, I just didn't want to take that risk of something that potentially would crack. You know, it's not SFI certified. I don't think it would ever fly apart. The 300 flex plate would probably work just fine long term. And remember, dimensionally it's correct, but I wanted to find something a little bit better. So I kept on shopping. So a couple days later, this guy showed up and I thought it was going to be a winner for sure. It was SFI certified. And from what I could tell, based on the catalog, it should fit exactly where I need it to be. The only problem was, this is for an externally balanced engine, and as you can tell, there's a counterweight welded on right there. But I knew that going in, and I kind of figured it'd be easy enough just to cut a couple of welds, grind it nice and flat, not to damage the face of the flex plate itself, and this would be our answer to our conundrum. But it's not. It is a 14 1/4 inch diameter. It does have the same 164 tooth flywheel. And this is where things got a little bit interesting though, because when I ordered this, it was listed as having an 11.5 inch bolt pattern for the torque converter, where remember, mine, I actually measured it, is 11 3/8 of an inch. So I bought it thinking, well, all I'll have to do is just grind a 1/16 of an inch on the inside of these bolt holes on each side to make up that 1/8 of an inch difference in diameter. But luckily, as it turns out, this one measures in at 11 3/8 of an inch. So I don't know if maybe Ford guys just don't normally use a tape measure, or maybe it's just a rounding for convenience sort of thing. I don't know why there's that 1/8 of an inch discrepancy, but if you put a tape measure on that thing, it measures in at 11 3/8 of an inch. So anyway, all that aside, I threw the torque converter, I threw the flex plate onto the face of the converter, just kind of in the engine bay there, and everything lined up perfectly, and I'm like, great, we are good to go. And then just to kind of be safe, I pulled it out and I put the stock flex plate in there and did the same thing, and I quickly realized that is not going to work at all. The spacing of the depth of the flex plate, totally different between the two. Now, when I was doing my reading the day before, whenever I ordered it, I had come across a post or something that said there's 2 different patterns of converter. There's a C4 and a C6, and the main difference from what I thought, anyway, was just the difference in the bolt pattern, and I had the right bolt pattern. But now we've got a whole nother variable, and that's the thickness or the depth or offset from the flange of the crankshaft. Now, I measured a couple different places just sitting on my table here, and it's kind of hard to get a good accurate measurement because it's not perfectly flat. But if you kind of take and you measure between the face of the flex plate and the table, just kind of with some calipers using the little end there for depth, boom, slide it down, and we'll zero it out. And then we come over here to compare. This one is a little bit deeper. 140 thousandths of an inch. Now, like I said, I did this a couple times and I got anywhere between like 140, 180, 190 or so, which more or less means if I bolted this flex plate up to that engine and that transmission way down in there, it would pull the converter out of the transmission by about 180 thousandths of an inch. That's like 3/16, which is fairly significant and totally not the right way to do it. It probably wouldn't work in the long run. So my next thought was like, all right, how do I fix this? How do I make this work? Do I get a crankshaft spacer? It's not really the right way to go, especially with something that thick. I mean, we're talking 150 thousandths of an inch, and you can buy spacers, but most of the spacers I've seen are like, 30 thousandths, 50 thousandths. I think I saw one that was like 75. So I'd have to have at least two 75s stacked together to make my 150 offset. But then that's going to throw off the position of the starter ring, which means the starter is not going to have the same engagement that it did before. So the short version is this flex plate is not going to work, even though I was hoping that it would. So now I start looking at a little bit more expensive flex plates, because I would consider these more like stock or heavy duty replacements. And they do make some like billet flat faced flex plates. And I thought, maybe I'll give one of those a try. But as it turns out, you can't use those with a stock torque converter because of the little ridge or the bump that's on the front. If you can kind of see down there, there's this raised lump or a ring. There's probably a piston there, something for the converter clutch. But basically, if you can't draw a flat line from the face of this lug across to the face of this lug, that flat flex plate is not going to work. Alrighty, so this literally just showed up, and I'm hoping this is the answer to my conundrum, to my problem, to this frustrating Ford fiasco, if you want to call it that. Here we go. Another flex plate. So this one, if I remember right, this is actually for a 351M or a 351 Cleveland. I think it actually would fit both. Now it is an internally balanced flex plate, which means no counterweight to grind off. And dimensionally, I just kind of am throwing darts at the wall here on this one. And I think this one might be correct, so I'll get it out of the box and I'll slap it up on the converter, see if it actually slides on. We'll double check our spacing. Fingers crossed, guys. I hope this one works. Alrighty, so this is kind of how I compared the different flex plates to see what was what. This is the original flex plate, original converter clearly, and if you look right here to kind of see the offset from the snout of the converter to the flex plate there, you can just barely see a little bit of a white oxidized line, like kind of where it's stuck in the crankshaft. So remember this spacing. You can just barely see the white line with the stock flex plate. So what I'm going to do now, put you guys down on the little cowling right here, if that'll stay. I'll swap the flex plate over. So original one out, new flex plate goes in. Let's see here, line it up on the studs. Boom, right on. And now let's see what we've got to work with. So it lines up on the studs, that is good. SFI certified, that is also good, but take a look down there and you tell me if you think that's going to work. Now, I generally like to consider myself a pretty patient person, and I usually put a lot of research into these projects before I start turning wrenches, just so I don't have any crazy delays or problems like we have here. But this Ford thing, this is really starting to drive me crazy. I don't know why those engineers over there decided to make so many different changes for the same basic engine and transmission combination, but you guessed it, the new flex plate does not fit. So let me kind of show you some of the differences between that and all the other ones that we have here on the table. So I got rid of the cardboard, so now I have a perfectly flat surface on the table, stock 5.8 351, stock 300 straight 6, and this is the new one for a 351M/C, I believe. So let's start with the basics. It'll bolt onto the crankshaft. It has the same 11 3/8 inch diameter spacing for the torque converter, so that's good. But the ring gear for the flywheel is actually a little bit different. It's at a slightly different height by the difference of about 70 thousandths of an inch. You kind of see those two right there. That's the 300, that's the new one. It's a little bit off, not a huge deal, but when you compare, say, the stock 5.8 to the stock 300, those are basically spot on. So now, that's not the only difference that prevents me from using this flywheel, because this has pretty much the same torque converter spacing as the gold one. Now, both of these applications are for like mid 70s to early 80s Ford 351 stuff, because on none of the parts websites, they don't list anything up into the 90s. And apparently that's where this problem comes from. It's either I don't think the engine is different, but I think the transmission and the torque converter, this E4OD, are just totally out of whack, and that's what's causing all these problems. So a couple solutions that I'm not going to use, but I'll just kind of walk you through my thought process. The difference in height between these two is 3 washers. That's like 180 thousandths of an inch right there. So what I could do is I could place these 3 washers on each of the 4 converter studs, kind of like that, and bolt it together. And that, in theory, would kind of work, but washers are definitely not a precise method of spacing, not to mention when you stack 3 of them together. So that's not a very good idea to start with. But then once you add the spacing of the extra washers and the slightly thicker flex plate, the bolt or the nut is not going to go on the stud all the way. It barely would start to grab. So we can't put the spacers on this side. We could put the spacer, or a single spacer rather, between the flex plate and the crankshaft, but then that would raise this dimension, or the offset of the starter, even further, which means the starter would probably strip out the teeth on the ring gear. So that's not going to work. That's not going to work without cutting the counterweight off, but that's an old flex plate. I don't want to use it. That one maybe would work, but it's kind of thin. Those ones don't work. So I'm just fed up right now. I kind of had it with this thing, and I'm just venting at this point, to be honest. But there's one more solution that I have found, but it's a very expensive one, and I don't know if it's one that I want to take yet or choose just yet. And that's a different torque converter and a flat flex plate. I believe it's Circle D, will make a torque converter kind of for a Ford Lightning first gen application, E4OD 351, and it's a torque converter with a flat face. And I can pair that with a flex plate, one of those billet flat flex plates, but total that option is going to be like $1,500 or $1,600, because that's a different torque converter, a different flex plate, and I'm not entirely 100% positive that that's going to work. Now, I did find a flat flex plate for a 351 that is internally balanced, but because of all these issues I'm having with all this different converter spacing from like weird early 80s to early 90s stuff, it's just totally messed up. And I'm venting now, sorry guys, but this is so frustrating that I'm having a problem. This is super simple. We could LS swap this thing and put junkyard parts in, and it would work all day long. And not that this truck deserves an LS swap. It's a really nice Ford. And down the road, I kind of mentioned we are thinking about converting to like a new 8 or a 10-speed automatic, and that'll present a whole new slew of challenges. But the option I'm leaning towards, and I really hate to say it at this point, is I'm just kind of leaning towards using the Ford 300 straight 6 flex plate, because it works without having to use any sort of a spacer. It'll bolt right on. It's for an internally balanced engine. All the spacing is on, whatever. But it's a little bit thinner than I would like, and it'll probably get by, but it's certainly not ideal. That's why I spent all this time, because when I put stuff together, I want it to be right. And if I put this flex plate in there, I'm just not going to feel great about it. It'll probably work. It'll probably work for a very long time, but I'm not going to feel great about it. But at this point, the only alternative that I see is spending like another $1,500 or $1,600 on a different converter and a different flex plate. And I'm just scratching my head, guys. So at this point, I'm going to call this video quits. I've got to go do some editing. It's Friday afternoon for me. Have a safe and happy 4th of July, guys. I appreciate you watching. I appreciate you listening to me rant. Hopefully somebody out there maybe has a solution. One other thing I found is somebody makes an SFI flex plate for a 351 Lightning, which I think in theory that would be the closest thing that I could put on here. But that is one of those, it's an externally balanced flex plate, and it has, like, you see these little notches here? It's got like 1 million of those cut out, which I think would throw off the balance. So even if I got that one, cut off the counterweight, it would not be perfectly balanced. But anyway, I don't know what else to say, guys. I'm frustrated. I hate Fords. Thanks for watching.